Hi guys, so welcome. In the last video we have learned how to calculate stress for a load like this or simple tension like this in any plane, whether it is like this or this, whatever may be the angle or phi. We have already learned how to calculate the normal stress and the shear stress in this plane. Okay, so in this video we learn how to calculate the stress in this plane when the stress is acting like this and like this. Okay, so your stress is applied in both the mutually perpendicular axis. Okay, so let's start it. The very first thing you may think, in which cases this type of stresses are acting. Okay, how normally in case of simple tension we normally observe this type of stresses or loads are applied, but where this type of stresses are applied, let's say, so you must have heard of boiler. Okay, a boiler looks like this, and these are two spherical end, and this is under tremendous pressure. The pressure is being applied everywhere. This is a cylinder and these are spherical in 3D, half spherical. Okay, so now if you take any part here, this element is under the action of two stress. One is acting like this and another is acting like this. So if this is the x direction, you can say this is sigma x and this one is sigma y. And you know already that sigma x can be calculated by like this. Let's say this is the half part of your boiler. Okay, and your sigma y is acting like this along the length. So if the total length is L, for two side it is 2L, if thickness is T, and let's say the acting stress is sigma y, in that case it must be equal with your total pressure P, and this is acting on plan area D multiplied with your L. D is the diameter. So your sigma y will be like this, P multiplied with D divided by your 2 times thickness. This is your sigma y acting on the boiler and on this element. Okay, and what about sigma x? Okay, to calculate sigma x, you cut the boiler anywhere like this and it will look like this. This is the face, this is the tail. Okay, and your stress is acting like this. So if the thickness is again T, total area for acting this stress is your pi multiplied with D diameter into thickness T. Let's say this is sigma x. It must be equal with your total pressure distribution is your, let's say, P, and area is pi by 4 by D square. So your sigma x is coming as your P D divided by 4T. Okay, so now you have identified the value sigma x as this one and your sigma y as this one, and it is also clear to you how these stresses are acting. So now our task is to find the stress. Let's say this is your original axis. Okay, we have to calculate stress in plane which is making angle phi, okay, with this vertical axis. In the last video you have already learned, due to this sigma x, how you can calculate the stresses on this plane. If you cannot remind, in that case the sigma normal stress is this one, okay, and shear stress was this one. I have already discussed thoroughly these two things in the last video. If you have not seen yet, you can see it. So now we have to calculate this for sigma x as well as for sigma y. Okay, so for first sigma x, let's again rewrite it For sigma x, the normal stress was, let's see, what was it? It was something like this: sigma x multiplied with cos square phi. Sigma x, let's say this is sigma in dashed, okay, cos square phi. And what about your shear stress? It was your sigma x by 2 multiplied with sine 2 phi. Sigma, let's say this is tau dash, sigma x divided by 2 multiplied with sine 2 phi. Now check, or let's see how this phi has been measured. Okay, so phi has been measured. This was your acting stress, and you have measured your phi, and this was your normal stress sigma n. So to calculate this normal stress, you have measured your phi in anti-clockwise direction from the acting stress. Clear? There is no doubt about it. Now if we have to calculate stress due to sigma y, let's see how the angle is measured. Okay, so for clarity I am again drawing this picture. So this was your sigma x, and you have already learned this. Now it's time for sigma y. This is your sigma y, and our plane was like this. Okay, and we have already measured phi. This was sigma n dashed, or the normal stress due to sigma x. We have measured phi in anti-clockwise direction. Okay, now what is the angle made by this stress with sigma n? Simply this angle, what is this? This is your pi by 2 minus phi. Any doubt? But here you have measured this angle with respect to this stress in anti-clockwise direction, but here in clockwise direction. So you have to put a minus sign. So phi dash, or the angle due to this stress, for finding normal stress in this plane, is coming as minus multiplied with pi by 2 minus phi. So if you have to calculate normal stress and shear stress for sigma y, you have calculated with for sigma x, now calculate for sigma y. Simply put phi dashed instead of phi. So let's define with sigma n double dashed. It is coming as sigma, not x, it is y into cos square. Instead of phi, it is minus pi by 2 minus phi. Okay, so it will come as your sigma y sine square phi. Okay, and what about your tau? Let's denote with tau double dashed. Okay, so tau dashed is coming as your, let's see what was the formula for tau. It was sigma x by 2, so sigma y by 2, and sine 2 times phi, that is minus pi by 2 minus phi. Okay, and it is again coming as your sigma y by 2 multiplied with sine 2 phi. Okay, you can check this operation. If you don't know the formulas or this operation or relations, you may consult any trigonometrical books. Okay, let me check for at least one. Let's check for this one whether it is right or not, this operation. Okay, it will be checked for me also. So sine of 2 minus pi by 2 minus plus 5. Okay, minus pi and minus minus plus. So again sine minus pi plus 5, or sine of minus pi minus 5. Okay, and sine of minus means minus will come here, so it is sine pi minus 5, or minus sine pi minus 5 means sine 5. Okay, sorry, there is a mistake. This is 2 phi, this is also 2 phi, this is also 2 phi, so it should come as minus sine 2 phi, and I have written plus, so I've made a mistake, that's why I have checked. So your tau dash is coming as minus sigma y by 2 sine 2 phi, and sigma n double dash, or the normal stress due to your sigma y, is coming as your sigma y multiplied with sine square phi. Clear? So what is the total stress which is acting on this plane? So if this was your member and this was your plane which is making angle phi, this is sigma x, this is sigma x, this was sigma y, this was sigma y. So what is the normal stress in this plane, or let's say this is pq? So normal stress sigma n, sigma n is equal to sigma n dashed plus sigma n double dashed. N is due to sigma x, this is due to sigma y. So sigma n dashed has come your sigma x multiplied with cos square phi, and this we have just derived, it is sine square phi, so plus sigma y sine square phi. Okay, so if you are given with sigma x and sigma y like this, and you are asked to find stresses, normal stresses on a plane which is making phi, so just by this simple formula you can find out what is the normal stress acting on this plane. And what about this your shear stress on this plane due to this sigma x and sigma y? So again sum of tau is equal to tau dash plus tau double dash. Tau dash was sigma x by 2 multiplied with sine 2 phi, and sigma tau double dash was your minus sigma y, this one for sigma y, so minus sigma y by 2 sine 2 phi. So simplify this, tau is coming as your sigma x minus sigma y by 2 multiplied with sine 2 phi. So again by using this formula you can find out the shear stress acting on this plane or on this PQ plane due to this stress condition. Okay, so in last videos you have learned for a single stress, now you have learned for your biaxial stress. Clear? And it's time for some implication. What is the implication of this formula? This is being said by this formula that if your sine 2 phi is 1, okay, in that case your tau become maximum, and the value of this maximum shear stress on plane is coming as your sigma x minus sigma y by 2. This is the implication of this formula. And for that, what should be the angle of this plane? Obviously if sine 2 phi is equal to 1, in that case 2 phi is coming as your pi by 2 and phi is coming as your pi by 4. So very important implication. And in question MCQ questions like exam like ESE, these are many times has been asked which is the angle for maximum shear. So the answer is your pi by 4. Okay, and in the last video you have seen that for uniaxial stress, or for stress like this, we have find the stresses, both normal stress sigma n, sorry this one is your sigma x So we have find sigma n and also the shear stress by your graphical representation. Okay, if you have forget, let me remind you. Let's see whether it is there or I have deleted. Oh yeah, it's there. So we have also calculated by graphical representation the stresses acting on the plane PQ, both the normal stresses and the your shear stresses. So this was for your uniaxial stress or only for sigma x. Now we have calculated mathematically what is the stress acting on plane PQ for sigma x and y. Okay, these are the mathematically proved formula. Let's say, sorry, let's check uh, whether the graphical representation also give us the same formula or not. Okay, so after discussing this graphical representation, we will end for today our lesson of strength of material. So start. First, this is the coordinate axis system, and this is the x direction, this is the y direction. Y direction represent your shear stress and x direction represent your normal stress sigma n. Okay, and this is the positive side, this is the negative side, this is also positive side, this is your negative side. Okay, so let's start. First, this was our stress condition. Okay, this was our material or body. Sigma x was acting like this and sigma y was acting like this. Okay, so we have to calculate stresses on a plane which is making phi angle, and the name of this plane is, let's say, PQ. So first, when your phi is 0, okay, when phi is 0, this is the plane and the stress acting here is sigma x. Okay, let's say this is sigma x, and when your plane has make 90-degree angle or phi is equal to your pi by 2, in that cases this is the plane and here the acting stress is your sigma y. Let's say this is your sigma y, and we have assumed sigma y is less than sigma x. Maybe sigma x is less than sigma y, but for now we are assuming this one. So our very first step is, let's name it. This is A, this is your B, and as we have done in case of our unique axial stress also, this was A, this was O, and we have made a circle by using OA as your diameter. Okay, so similarly here also, using AB as the diameter, we will make a circle like this. This is not a perfect circle. Okay, so our first step is complete to draw the circle, okay, by using AB as diameter. Second step is we have to identify the center. This is the center. Okay, this is the center, and this is center O, so origin O. So OB is your sigma y and OA is your sigma x. So simply this center is sigma x minus sigma, sorry, plus sigma y by 2. Okay, so this is the ordinate of this center. And what is the radius? Simply the radius is sigma x minus sigma y by 2. So you have got your radius, you have got your center, and you have draw your circle. So let's say you have to find stress on this PQ plane which is 5 degree away. Okay, and what we have done in case of uniaxial stress, we simply have rotate this radius anti-clockwise for angle 2 phi. Here also we will done that. So for 2 phi, let's say it is coming somewhere here, and this angle is your 2 phi. We have rotated it anti-clockwise. So let's say this is the point D, and the normal stress corresponding to this point will represent the normal stress here, and the shear stress corresponding to this point here will represent shear stress here. Okay, so find the values of this shear stress and normal stress by this graphical method. For clarity, again draw it. This is the axis, and this is sigma x, sigma y. Okay, A, B, this is the center, this is sigma x plus sigma y by 2. Okay, this is our circle, and now we will rotate our radius anti-clockwise manner with angle 2 phi. So this is point D. What is the normal stress? Normal stress is represented by this point. Let's say this is your DC, okay, and this is E. So normal stress is, if this is origin, so normal stress is denoted by your sigma n, or that is equal to OE, or OE means your OC plus your CE. OC is, you know, the coordinate is sigma x plus sigma y by 2 plus CE. What is CE? CE is the cos component of this hypotenuse or radius, or CD. CD is no sigma x minus sigma y by 2 cos component cos 2 phi. Clear? And what about this shear stress? Shear stress is the sine component of this hypotenuse or CD. So tau is coming as your CD sine 2 phi, or CD is sigma x minus sigma y by 2 sine 2 phi. Clear? So let's check with mathematical calculation. For tau, this is sigma x minus 2 or sigma y by 2 multiplied with sine 2 phi, and our mathematical formula says yes, this is correct. And what about the normal stress? Normal stress is being denoted by sigma n, and it is expressed by this formula, where it is sigma x multiplied with cos square phi plus sigma y sine square phi. But here I think something else has come. So what is the result here? The result is this one. If you simplify this, this will come as the same formula. Okay, and this simplification is not part of this video. This is a trigonometrical class. My request to you, please check it by yourself whether these two formula are same or not. Okay, this means this formula and your this formula, this should be identical. That's all. In the next video of strength of material, we will discuss about the very important topic, which is very useful for your GATE, your ESE, whatever it is. Just don't think about the exam, think about the actual topic or the subject. It is the principal stress. Okay, so don't miss that video. And till now, if you have not subscribed it, please subscribe it to get the video on daily basis on each and every topic related to your civil engineering subject.